Factors that influence the formation and development of soil in various soil properties. Good morning, and this is Ronan B. Torres Jr. from BSA 1A4. Soil science. It is the study of soil as a natural resource on the surface of the earth, including soil formation, classification and mapping, physical, chemical, biological, and fertility properties of soils, and these properties in relation to the use and management of soils. Relief features, parent material, atmosphere, vegetation, and other types of life, as well as time away from human activities, are the key factors responsible for soil formation. Climate is probably the most important factor that can shape the formation of soils. Two important climatic components are temperature and precipitation. They determine how quickly weathering will be and what kind of organic materials may be available on and inside of the soils. Biota or organisms comprises all living organisms such as bacteria, fungi, plants, animals that can inhabit a given area. For example, one can speak of the global biota, oceanic biota, terrestrial biota, biotas of forests, bogs, lakes, and etc. Why is biota important? The role of soil biota is vital to soil properties and soil components. They break down soil particles for soil quality and soil function. Their leaves, stems, and other surface organs play an important role in maintaining soil properties and improving soil organic matter. Topography. Slope and aspects affect the moisture and temperature of soil. Steep slopes facing the sun are warmer. Steep soils may be eroded and lose their topsoil as they form. Thus, they may be thinner than the more nearly level soils that receive deposits from areas upslope. What does topography do to soil? Well, topography has a significant impact on soil formation, as it determines runoff of water, and its orientation affects microclimatic, which in return affects vegetation. For soil to form, the parent material needs to lie relatively undisturbed so soil horizon processes can proceed. Parent material is the starting point for most soil development. The parent material may be mineral rock or organic matter. When parent material is exposed to the atmosphere, or when organic matter and minerals are deposited on the Earth's surface, soil formation begins. Role of parent material in soil formation. The parent material of a soil determines the original supply of those nutrient elements that are released by weathering and influences the balance between nutrient loss and retention. Organic acids and exudates produced by microorganisms and plants enhance the weathering of minerals and the release of nutrients. Time is perhaps the most important factor when it comes to soil formation. Everything takes a very long time indeed. In fact, it takes around 500 years to create just under an inch of topsoil. On the other hand, it can be destroyed in next to no time through erosion, degradation, or cultivation. How does time affect in soil formation? Time is the fifth factor in soil formation. Over time, vegetation and climate act on parent material and topography. Development, not chronological age, determines the soil's age. The degree of aging depends on the intensity of the other four soil-forming factors. Soil development. Soil develops through a process involving weathering, fracturing, and comminution of rock into mineral soil particles. These processes evolve at varying speeds, depending on the intensity of the factors that are brought to bear. Chemical weathering. The principal chemical processes that result in soil formation through chemical weathering are hydration, oxidation, carbonation, and leaching. The product of chemical weathering is generally fine-grained soil. Some examples of chemical weathering are rust, which happens through oxidation and acid rain, caused from carbonic acid dissolves rocks. Other chemical weathering such as dissolution, causes rocks and minerals to break down to form soil. Physical properties of soil. Physical properties of soil include color, texture, structure, porosity, density, consistency, aggregate, stability, and temperature. These properties affect processes such as infiltration, erosion, nutrient cycling, and biologic activity. It is one of the most important soil's physical factors controlling or modulating the flow and retention of water, solutes, gases, and biota in agricultural and natural ecosystems. Soil structure is very important in soil productivity and is a limiting factor of crop yield. Soil structure is also known as the arrangement of the soil particles into aggregates. The 8 primary types of soil structure are blocky, crumb, columnar, granular, massive, flatty, prismatic, and single grain. Now, let's discuss the 8 primary types of soil structure. We have granular and crumb. Structures are individual particles of sand, salt, and clay, grouped together in small, nearly spherical grains. Water circulates very easily through such soils. They are commonly found in a horizon, or also known as the topsoil, in soil profile. We also have blocky and subangular blocky structures. These are soil particles that cling together in nearly square or angular blocks having more or less sharp edges. Relatively large blocks indicate that the soil resists penetration and movement of water. They are commonly found in the B horizon where the clay has accumulated. Prismatic and columnar structures. These are soil particles which have formed into vertical columns or pillars separated by miniatures, but definite vertical cracks. Water circulates with greater difficulty and drainage is poor. They are commonly also found in B horizon where clay is accumulated. Flatty structure is made up of soil particles aggregated in thin plates or sheets, heeled horizontally on one another. Plates often overlap, greatly impairing water circulation. It is commonly found in the forest soil, in part of a horizon or the topsoil, and in claypan soils. And we also have biological properties of the soil. It represents the direct and indirect influence of living organisms habitating a particular soil. Biological properties includes organic matter, soil organisms, and the presence of disease-causing organisms. Organic matter. 2 main parts of soil are inorganic matter and organic matter. The inorganic part is the non-living parts, which are salt and clay particles. Organic matter includes all the decomposing plant and animal material in the soil. It makes an important contribution in the chemical and physical properties of the soil. Decomposition. The breakdown or decomposing of organic matter and can help the soil structure. It also gets rid or dead things and helps recycle nutrients. Microorganisms and soil animals do decomposing. They turn organic matter into humus. And when we say humus, when plants and animals have completely decomposed and lost their structure, the material formed is called humus. To describe, it is a dark, spongy material which forms a coating on the inorganic soil particles. All organic matter in the soil will eventually decay to humus. Advantages of organic matter. Increased supply of available nutrients for plants as it is broken down. Increased water holding capacity in sandy soil because organic matter holds water. A greater amount of air in the soil because the organic matter opens up pore spaces by forming crumbs, especially important in clay soils. Raised soil temperature as dark color of the organic matter absorbs and holds heat. In addition to supplying nutrients to plants, organisms benefit plant in a variety of other ways, including retaining nutrients in the soil, preventing them from leaching, competing with inhibiting and consuming diseases, decomposing plant residue, toxic material and pollutants that kill plant roots, and forming soil aggregates that improve water infiltration, root penetration, and water holding capacity of the soil. The presence of disease-causing organisms. The agents that cause disease fall into 5 groups: viruses, bacteria, fungi, protozoa, and helminths or worms. Protozoa and worms are usually grouped together as parasites and are the subject of the discipline of parasitology, whereas viruses, bacteria, and fungi are the subject of microbiology. Soil health is the foundation of productive farming practices. Fertile soil provides essential nutrients to plants. Important physical characteristics of soil-like structures and aggregate. The reason that soil quality matters is that healthy soil can store and process more water. Poor quality, depleted soil won't hold water and will make it impossible for your plants to thrive and survive. The key to healthy, high-quality soil is lots of organic matter, things formed by organisms. That would be all for today, and thank you for watching.